Welcome back, everybody. My name's Mr. Swaner, and today we're going to talk about multiplying and dividing exponents, but this time we're going to do it with some coefficients. Before we begin, make sure you pick up your notes so that you can follow along to this presentation. And let's start with just a brief review on our multiplication of exponent rules. And those rules were, if we have the same base and we're multiplying two numbers together, that I can add the exponents and keep the base. Base is 2, 4 plus 5 is 9. And remember, I can do the exact same thing with variable bases. So long as the bases are the same, I can keep the base and add the exponents together. So let's start off nice and slow here. The first thing I'm going to do is I'm going to color code so that I can easily see which terms are alike and which terms can be combined. So here I have a 3 that cannot be combined with anything, and I've got an x to the 5th and an x squared. Those are like terms. I can go ahead and combine those together, but again, my 3 has nothing to go with, so I'm just going to bring it down, and that's going to be my final answer, 3x to the 7th power. Let's look at another one just like that. I'm going to color code everything. So I've got a 7 that cannot be combined with anything. And then I've got x cubed times x to the 4th. So I'm going to combine those to be x to the 7th. And I'm going to bring my 7 down because it has nothing to combine with. And that's going to be my final answer, 7x to the 7th power. Well, let's look at one with two terms with coefficients. We're going to do the same thing. Let's color code everything so that we know which terms are going to be combined. So now I've got 3 times x to the 5th times 4 times x cubed. Remember, this is just one giant multiplication problem. So I've got a 3 and a 4 that can be combined. That's 3 times 4. And then I've got an x to the 5th and x to the 3rd that can be combined as well. So let's combine those x's. That'll give me x to the 8th. And then 3 times 4 is 12. That's my final answer, 12x to the 8th power. So let's do another one just like that. I'm going to rewrite it so that I've got my like terms colored. And now I've got 5 times x cubed times 4 times x to the 9th. This is one big multiplication problem. So let's get the x's together. That'll give me x to the 12th, and then 5 times 4 is 20. So my final answer here is 20x to the 12th power. Well, here I've got 4x cubed times 2y to the 5th, and when I do some color coding here, I see that I have 4 times 2 that I'm going to do. I've got an x cubed, and I've got a y to the 5th. So my x cubed and my y to the 5th are not going to be combined with anything. So I'm just going to rewrite those down at the bottom. I know I don't have to deal with them. And then now I have 4 times 2, which is 8. And I'm going to rewrite my answer without the multiplication dots because I really think this looks a lot nicer. Okay, so let's look at another one just like that. I'm going to rewrite it with color coding my terms. So I've got a 3 times 2 that I'm going to do. And then x to the 4th and y cubed have nothing to combine with, so I don't even need to deal with them. I'm just going to move them down. And now 3 times 2 is 6. And let's rewrite our final answer without the multiplication dots. Let's look at one with 3 different terms. Don't get scared. Just because it's a little bit bigger doesn't mean it's any harder. We're going to do the same thing. Let's color code so that we can find our like terms. And it looks to me like we're going to do 4 times 3 times 2. Those are our like terms there. I've got an x squared and an x to the 5th. I can combine those, and then I have a y to the 8th, which cannot be combined with anything. So let's start with our x's. That'll give me x to the 7th power. And then I've got a y to the 8th power. Can't do anything with that, so we'll bring it down. And then lastly, I have 4 times 3 times 2. So 4 times 3 is 12. 12 times 2 is 24. We're going to rewrite our answer nice and neat. And I just want to give you another way of thinking of this. Remember, like I said, this is one giant multiplication problem, and I can use the commutative property to multiply in any order that I want. So the way that I think of this is I know I need to multiply 4 times 2 times 2. And I like to write my coefficients out front, so it makes sense that that would be the first thing that I do. And then I'm going to do x to the 6 times x squared. And then I've got an r cubed that can't be combined with anything. So we're going to go ahead and do 4 times 2, which is 8, times 2, which is 16. And that'll give me x6 times x squared is x8. And I've got an r cubed that can't be combined. So there's my final answer here. And we can do a lot of this stuff mentally once we truly understand what we're doing. So let's take a look at doing a couple of these using mental math. So let's just color code this stuff for us. So I've got a 4 that's not going to combine with anything. X squared times x cubed is x to the 5th. So my final answer here is going to be 4x to the 5th. Okay, so now I've got 3x to the 4th times 2x cubed. So I know I'm going to be multiplying 3 times 2. 3 times 2 is 6. And then I need to combine my x to the 4th and my x cubed. So I'm going to have 6x to the 7th. Okay, so 5x to the 7th times 6y to the 4th. I know I'm going to multiply 5 times 6. That's 30. And then I've got x to the 7th and y to the 4th. Those can't be combined together. I can't combine them with anything, so I'm just going to have 30 x to the 7th, y to the 4th. And we can do the same thing with larger problems. I see that I have a 2 times 3 times 4 that I'm going to do together. So 2 times 3 is 6, times 4 is 24. I've got an x to the 4th that can't be combined with anything. And then I have a y squared and a y to the 6th. I can combine those to be y to the 8th. So again, 2 times 3 is 6, times 4 is 24. I'm going to have x to the 4th and then y to the 8th. So let's talk a little bit about division, and let's briefly review our division rules. Remember that 7 to the 6th power literally means 7 times itself 6 times. And then we've got 7 to the 4th, and we can cancel out our 7 over 7s, because any number over any number, so long as it's the same number, will give me 1, and I don't have to deal with it. So I can cancel those out. And then I look at what's left. 7 times 7, that's 7 squared, or 49. And remember, we can do the same thing with variables. X to the 5th power just means x times itself 5 times. And I can do the same thing with an x over an x, because any number over the same number is just going to give me 1. And then I look at what's left. I've got x times itself 3 times. So that's going to give me x cubed. Well, let's dive right into this. Up in the numerator position, I've got 4x to the 4th power. So that means 4 times x times x times x times x. And then in the denominator, I have x to the 1st power, which just means I have x once. And let's look to cancel out my x over x. Then I look at what I have left up here. I've got x cubed and 4, so my final answer is 4x cubed. Okay, so we're going to do the same thing here. I've got 9x to the 6th power in the numerator position, so that's just 9, and then x times itself 6 times. And then an x squared at the bottom, that means I've got 2 of them. I'm going to cancel out top and bottom, and I look at what's left. I've got x to the 4th power. I've got 9, so my final answer is 9x to the 4th power. Well, let's look at something a little bit different. Now we have a coefficient in both the numerator and denominator positions, but we're going to do the same thing. There's just one last step that we have to do with our coefficients. We just have to reduce them, just like we're reducing our variables here. So let's draw this out. 4x to the 5th power is 4 and then x times itself 5 times. And then 2x cubed, that's 2x times itself 3 times. Let's go ahead and cancel out our x's. And then the last thing we need to do is look at our 4 over 2. And let's just think of this as a fraction, 4 halves. We're going to reduce that. Both 4 and 2 are divisible by 2. And we're going to reduce our 4 halves into 2 over 1. And remember, if the only thing left in the denominator is 1, we really don't need to include that. So up top I've got 2x squared, and if I wanted to, I could write this over 1, but I certainly don't need to, and it's definitely much nicer and much simpler if I just write 2x squared. Okay, so let's look at another one just like that. I've got 9x to the 7th power, so we're going to draw that out. And then now I have 3x squared. So let's cancel out our x's here, and then we're going to look at 9 over 3, and just like a fraction, 9/3. Both top and bottom are divisible by 3, so I'm going to reduce that to 3 over 1. Then we're going to look at what I have left. I've got 3x to the 5th power, and then I just have 1 at the bottom. Again, I could write it like that with a 1 underneath, but I certainly don't need to do so, and it certainly looks better just 3x to the 5th. So we're going to keep it like that. So let's throw in an extra variable and exponent. A little bit bigger, not any harder. So let's draw this out. 2x to the 4th, y cubed. And then on the bottom here, I've got 4x squared, y squared. And I lined up my y's with my y's just because it's nice and easy and visually pleasing, and makes my life nice. So x over x, I can cancel those out. I've got y over y, I can cancel those out. And then I'm looking at the fraction 2/4. So I can reduce 2/4 to 1/2. And then we'll look at what we have. Up top, I've got 1x squared y. And we don't need to write that one. We could, but it's much better without it. And then in the denominator, the only thing I have there is 2. So there's my final answer, x squared y over 2. Let's look at another one like that. So now I've got 12x squared y to the 5th. And then in the denominator, I've got 9x to the 5th, y to the 3rd. And looking at this, you can see that I'm going to be left with some x's down on the bottom, and that's certainly okay. So let's cross out our x's that we can. We've got 2 there that can cancel out. And let's cross out our y's that can be canceled out. And then we're going to look at the fraction 12 over 9. We're going to look to reduce that. So I need to be thinking, what number can I divide 12 and 9 by? The answer to that is 3. So I'm going to divide 12 by 3 to get 4, 9 by 3 to get 3. So I'm reducing 12/9 to 4/3, the equivalent fraction in its simplest form. And then let's look at the top. Up top I have 4y squared, and on the bottom I have 3x cubed. And that's my final answer. So let's see if we can do some of this stuff mentally. If I have 4x to the 9th over x to the 4th, we should see that my 4 is not going to combine or cancel or reduce with anything, so I can write that. And then we're just going to use our exponent rules. 9 minus 4 is 5. And that'll give me a final answer of 4x to the 5th. And we can do the same thing here. If I have 12x to the fourth, y cubed over 3x squared, you'll see that my 12 and my 3 can be reduced. 12 thirds is 12 divided by 3, which is 4. So I'm going to have a 4 up top and just a 1 on the bottom. And I can do some reducing with my x fourth over x2. That'll give me x squared. And y cubed will not combine or reduce with anything. So my final answer here is 4x squared y cubed. And we'll look at one of these larger problems. It's going to be the same thing. So 5/15, 5 over 15, both of those are divisible by 5, so I can reduce that to 1/3. And then my x7 and x4 is going to give me x3, and then you should see that I'm gonna have that y to the fourth left on the bottom there because there's only 2 up top to cancel out with. And that's my final answer there, x cubed over 3 y to the fourth. Let's look at just one more example. If I have 3x squared y over 9x to the fourth y to the fifth, we're going to reduce my 3/9 to 1/3. And then I've got x squared, x to the fourth. We're going to lose all our x's up top. They're going to be gone, and we're going to have an x squared on the bottom. And then we're also going to lose my y, because I have 5 of those on the bottom, so that'll leave me with 4 on the bottom. So we'll look, and the only thing I have in the numerator position is 1. And because there is nothing else up there, I need to keep that 1 there to hold that place value. And then I just look at the bottom. I've got 3x squared y to the fourth. That's it. I'm finished. And so are you. So in closing, when we are multiplying and dividing exponents with our coefficients, the easiest way to do this is to just break the problem into its like terms. And I recommend highlighting. You could rewrite it in colored pencils until you really get the hang of it. And then once you truly understand what you're doing, it's very easy to do this using mental math. Well, thank you very much for joining me. Again, my name is Mr. Swaner. And until next time, study strong and keep practicing.